Hey guys, welcome to the next video of Edustation. We make videos on those topics which we face problems and we don't want to let you. So therefore, any further delay, let's jump to the notebook. I'm starting this chapter from the Einstein photoelectric postulates because I don't want to go with the elaborative discussion, because you can find any other discussions on YouTube that is related to theory, but I am going to teach you the practical purposes for the practical purposes. So I'm starting from the postulates of Einstein. The postulates that Einstein gave us, if we mathematically use this, and we will get an equation that is telling that h nu equals to omega naught plus E max. Now we should know the denotions. We all know that h is the Planck's constant. Okay, and we know its value. What is its value? 6.626 into 10 to the power minus 34 joule per mole. And this is known as the threshold energy. If we say that what's the minimum energy needed to start the photoelectric effect, this is denoted with the omega naught. Okay, and this is the E max, that means the maximum kinetic energy of the electron that is coming out from a metal which is photoelectric effect. That means that shows the photoelectric effect. Okay, and this omega naught is known as the work function. Okay, I will discuss about it within a minutes, but we should know the denotions. So this is the energy, and this is written in electron volt, and this also, and therefore this also. Okay, now we know that if we tell in quantum mechanics, if we tell about any body that is emitting energy, that will be with the equation of frequency. That means if a body that is radiating a frequency nu, then the energy radiated is h nu, where h is the Planck's constant. We all know that. Let us take a plate, a metal plate, a metal who shows the photoelectric effect, and light is propagating on it. Now Einstein told that we should remember that when we are looking at light, we just know that it is nothing much but the flow of photon. Now what is photon? Photon is the quanta for light. That means the energy is carried by photon. Of whom? Energy of whom? The energy of light is carried by photon. Okay, photon is the packet of energy that is carried out by light. Okay, now this light, for this light, the metal emits electron. Okay, so we have to find out the maximum energy of whom the electron emitted. We have to find out the maximum energy, maximum kinetic energy. Okay, so from this equation, this is the mother equation, we should write everywhere. E max equals to h nu minus omega naught. Now this is known as the work function, I have told here before, and this has a really function in your mathematical operation. What does it do and what is it? The work function is the minimum energy that is required to start a in the photoelectric event. Okay, that means let us assume that a metal emits electron as a sign of photoelectric effect. A metal emits electron uh, uh, as the sign of photoelectric effect with the minimum light having frequency of nu naught. What I am trying to say, if a light is propagating on it which frequency is less than this, the photoelectric event will not happen. We have to the light is coming, the propagating on it must have the frequency greater than it or equal to. So if the light is carrying nu frequency, nu is a frequency, then to start the photoelectric effect, the frequency must be greater than the nu naught. That means it is the threshold frequency. Okay, so this is also energy. I have told here before, this is also energy. Therefore from this formula we can write that how much the energy will be, H nu naught, and this is the work function. Okay, it is different for the different materials used in the photoelectric effect. Now what I said before, that the E max or E is the kinetic energy, and we know that the kinetic energy of any moving body having the velocity v is half mv square. Now m is the mass of the body. Okay, so we can put this in this equation, and using h nu omega, that means the work function, as h nu naught. Okay, so half mv square equals to h nu minus h nu naught, and taking the h nu from both sides, and this is a very useful equation to solve the mathematics that comes in ICSE, CBSE or WBC HGC board. Okay, this is just a derivation from the mother formula, and this is so useful. And I am giving you example 2. This question came in WBC HGC on 2012, that for a certain element the threshold wavelength is for starting the photoelectric effect is 400 nanometer. Okay, now if a light having the frequency of having the wavelength of 200 nanometer is propagating on the metal, the electron emitted from the material, how much kinetic energy will it get? Okay, and you are given the Planck's constant, so the electron is coming out, and as we say from this equation, not like this, we don't need this because they didn't told us about the velocity. Okay, so from this equation we can derive that E max equals to h nu minus h nu naught, and we know that C equals to nu lambda. Okay, where C is the speed of light, then the frequency nu equals to C by lambda. So you can write this like sorry, now we know that the lambda naught is the threshold wavelength, that is the 400 nanometer, and this is the light that is propagating on the metal currently. Okay, so let us take out the common things outside and one by. Okay, so now putting the values, we will get 6.6 into 10 to the power minus 34 into 10 to the power 8 into 10 to the power 8. Why the 10 to the power 8 is coming? That because 400 nanometer equals to 400 into 10 to the power 9 meter. That means 440 into 10 to the power 8 meter. And if you take the 8 meters, then the power will be changed from negative to positive, and we will get 10 to the power 8. Samely, so this gives the result 3 into 10 to the power 8, of course, and this gives the result what is the 4.9 into 10 to the power 19 minus 19 joule. Okay, so this is how you should complete the problems. That means you solve the problems that is given in both in the exams or anywhere. You can use this. Okay. Now we often asked a very tricky type question, that photon is massless. That means it doesn't have any mass. Then how it can acquire momentum? Because we know that the body having both mass and velocity has the momentum. So photon doesn't have mass. Then how, if mass is zero, then how can the momentum be not zero? So this is the answer, because we know that momentum that is denoted by P is equal to mass into velocity, but it is in the classical physics. The new theory that quantum mechanics says that if a particle having energy P and momentum E, if a particle having energy E and it has momentum P, then E equals to root over P square C square plus m naught square C to the power 4. Now what is m naught? M naught is the rest mass. Okay, it is said that when a body at rest and when the body is in speed near about light, the mass is changed. Therefore, we should talk about the rest mass, and this is the c is the speed of light. Now, in case of photon, the rest mass is 0. Okay, then it is p square c square plus 0. That means p square c square root over, and we take the e. Okay, then the answer P E equals to PC, and we know that photon, when is in speed, carries minimum at least energy. Okay, so E is not equals to 0. C is constant, then C is not equals to 0. Therefore P must not be 0. Okay, and that's how mathematically you can prove that photon has momentum in spite of not having rest mass. One thing more, I think we should tell about that the relation between the kinetic energy, the maximum kinetic energy, that is denoted by Emax, okay, and the stopping potential. if you want that we should make a video particularly on stopping potential, then please comment down below. We will surely make it. Stopping potential, that is denoted with V naught. As we said before, that kinetic energy is always half mv square. Okay, and here v is the velocity, and here v is the potential. Okay, always remind this difference, that it is potential. This is potential and this is velocity. Okay, so we know that we have said it before, that E equals to EV. Now what is the relation? What is the relation? It is said that if the electron is in a situation that is a medium that having the potential V, then the kinetic energy of the electron will be the charge of the particle into the potential. Okay, so in case of stopping potential, the potential is V naught, and in case of the charge of electron, because we are dealing with the photoelectric effect where only the electron is emitted, the charge of electron. So this is the charge of electron, which is 1.6 into 10 to the power minus 19 coulomb in SI. Okay, and so from getting the equation both, we can say that half mv square is equal to EV naught, and as we are dealing with E max, because stopping potential is measured when the kinetic energy is at its highest point, the maximum. So here will be the E max also, and therefore V will be the V max also. So we are taking V max. Okay, so the value of V max will be root over 2 EV naught by M. So this is a equation, not only equation, this is a very much useful equation that is used when when you are asked to measure the stopping potential or the V max, the maximum velocity, either of V max or stopping potential is not given. Okay, this is one type of equation. So I think you can make any equation by deriving both of this equation, and I said the before equation, that is this, actually from the mother equation. Okay, thank you for watching this video, and if you want these videos in Bengali, then make sure you have told in the icon button.